Dear students, welcome back to another video by the Evergreen Mathematics Department. The chapter that we are looking at today is chapter 16, Data Handling. So we'll be looking at the part 1 of these notes. Okay, so for these notes, we would be learning how to interpret and handle data from pictograms, bar graph, line graph, and pie charts. Okay, I understand that you have already learned what is a pie chart in primary 6. So this part should be relatively simple for you, right? So these 3 parts should be the new parts which you should focus on. Okay, let's look at the first part of the notes. Okay, so some basic definitions. Why are we learning this chapter? This chapter falls under the branch of statistics, and statistics is the collection, organization, presentation, interpretation, and the analysis of data. Okay, so what we are going to do is that when we have data, we can collect them by taking measurements in experiments, right? So like, for example, when you do a chemistry experiment, you would like to find the total volume of gas, when you put a metal into an acid, for example. So at every 5-minute interval, you probably take a measurement, and these are the raw data which you obtain from conducting that experiment. Okay, so you can also collect data by observing outcomes of events. So for example, you stand beside the road, and in half an hour interval, okay, within half an hour, you would like to calculate the number of red cars that pass by, right, the junction, something like that. Okay, you could also conduct surveys, right, or read statistical publications. Okay, so the data collected are called what data? Right, raw data. Okay, because they have not been organized. Okay, it means that they are not organized in any way, right? Usually we like to organize them in ascending order or descending order, depending on whatever you require. Okay, after you organize the raw data, what can we do? We can actually present them in the form of table, diagram, and graph. Okay, so one of the more common diagrams that we use in statistics is known as the pictogram. Okay, the pictogram is a simple way of representing data where the frequency is indicated by the number of identical pictures, right? So for example, in this case, we are looking at the total number of goals scored in a football season by whom? Okay, by these 4, let me guess, maybe teams, right? The name of the teams are Dragon, Horse, Lion, and Tiger. So these are the 4 football teams and these are the number of goals that they scored in that season. Okay, the most important part of the pictogram is to indicate a key, right, to explain what each individual picture represents. Okay, so in this case, the key is that one whole football represents 4 goals, right? So a quarter of a football would simply represent 1 goal. Okay, so the above pictogram shows the number of goals scored by 4 teams in a football season. Right, the first part A, which team performed the best in terms of the total number of goals scored? Right, so it's very clear. Just by looking at this diagram, we will be able to identify that the team is Lion. Okay, because it has the most number of pictures in this case. Okay, so the next part, find the ratio of the total number of goals scored by Dragon to that by Horse. So basically they want Dragon to Horse. So what is the total number of goals scored by Dragon? So 1, 2, 3, 4, 4.5, right? So 4.5 multiplied by 4. And what is the total number of goals scored by Horse? 1, 2, and 3/4. And you multiply that by 4. Right, so the simplest form will give us 18 to 11. Okay, so that is a relatively simple question. That is question 1. Let's look at the next part, bar graphs. What is a bar graph? A bar graph is one that can represent data by using rectangular bars of equal width that are equally spaced. Okay, so usually we can draw the bars vertically or horizontally, right? the vertical one would be the more common one, okay? And each bar represents a fixed category, right? The length and height of each bar is proportional to the values of the category represented, okay? And like I mentioned, the space between the bars must be equal. Okay, so for the first question, question 1, what we are looking at is a stock, okay, of grades A, B, C, and D. And these are stock of a T, right, in this shop. And it's actually shown in this table. So grade of T given by the 4 categories and their masses respectively. So the question wants us to find the total mass of T in this stock. How can we do that? Very simple. So the total mass is simply the sum of all these values from the second row. So that would be 5 plus 10 plus 13 plus 8. And this gives us 36 kg. Okay, so we are done. So next, we need to represent the data by a bar graph. Okay, so in order to do that, we must have very clear horizontal and vertical axis. So I would draw the axis first. Okay, so this is my vertical and this is my horizontal axis. Okay, what I would like you to do is to make sure you use a pencil and a ruler. Okay, I want to see your graph that you draw being very neat and presentable. Okay, and next you fill in your axis, which is basically your category given by the question. So this is the mass, the vertical axis represents the mass, and the horizontal axis represents the grade. Okay, so using a rectangular bar with equal spacing, right, I can show that this first grade of T given by A is of mass 5 kg. So each interval, right, let it be equal. So 5, 10, I choose multiples of 10, of 5 in this case, and 15, right? Okay, so the first one is done, right? The second one, grade B, what's grade B? 10, so same thing. This would be the graph for grade B. Grade C is 13, so I should be looking at this height where each small square represents 1 cm, 1 kg. So this is 13. Oops, this is not O, this is C. And finally, grade D, we should be looking at 8, so somewhere here. Okay, right, so that is our bar graph for this question. Okay, part C, which of the grade has the lowest stock? So it's very clear from the graph, we simply have grade A. Okay, and we are done. So I would like you to try question 2 on your own. I will skip to question, or rather skip to page 5. So I will roughly explain what's a line graph, and I will leave the pie chart to you since you have already learned it in primary school. Okay, so a line graph is another way to represent data, right? A line graph is drawn by plotting points, right, corresponding to the data and joining these points by line segments. I'm very sure by this time you should be able to plot the points even with your eyes closed. Not literally, right? Because you have already learned, in fact, the topic on coordinates and functions, right? So you should be able to plot these points very, very quickly and accurately, okay? Right, so for the second pointer, okay, a line graph is usually used to show trends or changes in certain variable over a period of time, okay? So for data that are time-based, we usually would want to use line graphs. Okay, and on the line graph, the values between 2 successive readings may not have the same meaning. Okay, so let's look at the first question. The line graph shows the changes in the body temperature of a patient from 6 a.m. to 12 a.m. on a certain day. Right, so this is given by a line graph. Right, the first part Part A, what was the highest body temperature of the patient and when did that patient have that temperature? Okay, it's very clear, right? From the line graph, the highest temperature is given by this point, and if you were to read it off carefully, right, you realize that the highest temperature is 40 degrees Celsius, right? And at what time did the patient have this temperature? This is simply at 9 p.m. Okay, so 40 degrees Celsius is actually a fever, a high fever. Okay, for part B, find the number of readings for temperatures above 37 degrees. So, drawing a vertical line passing through 37. Right, above means should you include 37 or not? So, strictly more than 37. So you should not include the 37 degrees Celsius reading. So, and how many of such readings do I have? Right, based on the graph, 1, 2, 3, and 4. So 4 readings. Okay, try question 2 on your own and look at the pie chart on your own.